Whew, okay. Well, I don't know if that's really a good thing. Okay, guys, for the do nows. I just already checked homework. That's why we're getting right to it. And I might have board problems today. We're hoping. We're hoping that I don't, but I definitely have board problems. Okay. Is this not going to write? Oh, it's going to write. Yeah, this is day 2 of AP review. That rhymed. Okay, so here's the thing, guys. Sometimes instead of an X, you have to integrate some, like it'll be a 2x instead of an x or 3x. So it's use substitution if it's not just x, but it's a baby use sub. So, and sometimes these you can, once you get the hang of these, you really don't have to write out u, du, make the substitution. You can just see it. So what would it be then? You said you put a half outside. So what would you get for an answer? That's right. You'll get 1/2. It'll just be like if you integrated e to the x, you'll get e to the x plus c. But if it's e to the 2x, you're going to get 1/2 e to the 2x plus c. Now I know that just scared a lot of you, but here's the real work. But I want you to be able to see just going from here to here. If it's not just an x, if it's a 2x, you would need to put a 2 in, so you'll have a half out front. But now let's look at the actual work. So u would be 2x, du is 2, right? That's what you would need, right? So you would need a 2 1/2. And when you go to rewrite it, you have 1/2 the integral of e to the u du. And the antiderivative of e to the u du is e to the u, which gives us this. But do you see how you could really maybe avoid a little bit of work? If really it's just a 2x instead of an x, bless you. So with that in mind, let's look at the second one over here. We want to integrate secant squared of 3x, and Gina thinks she's up to it. I don't know. I'm sorry, I just put a lot of pressure on you. Okay. Okay. Perfect. She's saying it all perfectly. Okay. So if we rewrote it now, the integral of, and what is the antiderivative of secant squared u as long as you have du? What is tan? Right. So you'd have 1/3 tan u plus c. And so our final answer would be 1/3 tan of 3x plus c. Now that's a lot of work, right? If do you think you could ever go from just the original to the answer? I think you could. I think you could. You know, if you want to do all the work and confirm it, that's great. I think I have 2 more for you to practice. I think I have 2 more for you to practice. Pressing the button. There's Ashley. She's cutting. So let's see if we can do this one without any steps. I'm teaching you guys to cut corners. Isn't that horrible? But if you know what the antiderivative of sine x is, look at the chart. What the antiderivative of sine of 3x? Cameron. Oh, I almost got you. It was hard. Yes. Oh, I thought you were forgetting this, but then you snuck in divided by 3, didn't you? So that's the same thing. -1/3 cosine of 3x. Is that what you were going to say? I knew it. Does anyone want to see the steps for that? That was a good one. All right, the last one, I don't know. I don't know if you're going to see it. Oh, man, he sees it. Shh, she saw it. Yep. Simone forgot to say. It's so funny because her name starts with the letter C. Now, oh, So yeah, if you were going to do it the long way, you would need a 5 up here. For it to be a du over u, you would have a 5, and then you'd have a fifth. So you'd have a 1/5 the integral of du all over u, which is 1/5. Oh, yeah, I would put it there. Ln of u plus c, but good. Alrighty, so, should I show you the calculator stuff, then we'll go over the homework? Yes. Now, yes, I'm thinking about this. By the way, so tonight's homework, why? Why would just this one feature not work and everything else works? If you look at tonight's homework, that's bizarre. It says calculator section, multiple choice 76 to 92. Now, last night you did 1 to 28. Those were no calculator multiple choice. There are no questions 29 to 75 on the AP exam. I think it just goes because of the Scantron. So you use the first Scantron 1 to 28, no calculator. Then the second Scantron, for some reason, starts at 75. So the questions that pick up at 75. So I don't think there's so many questions. There's only 17 calculator questions. One thing I didn't mention on here, on average, you have about 3 minutes per question for the calculator multiple choice. So when you're doing them tonight, you want to think of that. And remember, the multiple choice questions count for half your grade. You can get 54 raw score points out of a total of 108. And if you can get 70 raw score points altogether, that's a 5. Around. Just guess right, I guess. Okay. As far as what you got to be able to do with your calculator on the calculator section, there are a couple things that the AP exam says you have to be able to do. First thing is you got to be able to graph. All right, I know you know how to put something in y equals and graph it. The big thing when you graph anything, make sure your x min and x max are good. A lot of times they'll give you the interval to graph, and that's what you want to put in for your x min and your x max. We'll try a sample. The second thing you want to really be able to do is solve an equation. Find the zeros or solve an equation. The way I like to solve equations on the calculator, you put one side in y1, put the other side in y2, and see where they intersect. The x-coordinate where they intersect, that's your answer. The third thing you got to be able to do is find the derivative of a function at a given value. That's the n deriv, math 8. Put in the function, comma x, comma the number. For the finding the derivative, it's math 8, which will make n deriv show up. Then you put in whatever the function is. Don't take the derivative yourself first, because then you'll be getting the second derivative. Then you comma x, and then whatever the number is. I'll just put a here. So yeah, if you want to get f prime of a using your calculator, use math 8, the function comma x comma a, whatever that number is. The other thing you have to be able to do with the calculator is evaluate a definite integral. So if you have to evaluate a definite integral of some function, you want that fnint. Do you remember where to find that? Math 9. Then you got to put in the function you wish to integrate, so that's your f of x, comma x. And on the calculator, do we put the lower or the upper first? Lower. A, comma b. So just to make sure that you guys can do this, I just have an example, a couple of examples. Yep, I do. They're there. They are. Just got to get to them. So try each of these always to the nearest thousandth, and you got to be in radian mode. Got to be in radian mode. Does anyone need to borrow a calculator? It's just sine of x plus 3. Yeah, it's not in the argument for sine. Does anyone else need a calculator? Come on up. So yeah, 1.382. Sorry, missed the explanation. Oh no. Oh, this works. That's nice. Okay. Ooh, I didn't ask you guys. What'd you get for the second one? I'm showing both of them. Oh no, no, I'm not. It's covered up. Okay, so you had to put in the end derivative 1.099. Got it? And the last one, 0.740. If you're not in ready mode, you're not going to get the right answer. So, can you get that? Did you square the cosine of x or just the x? Just the x. Yeah, just squaring what you want to square. That's how you roll. Okay. Let's look at homework. I know I gave you like the quick little solutions, like the printout. And I want to go over as many as we can. All the ones that are confused. Oh, Jessica. Hmm? That is awesome, Jessica. Proud of you. Okay, questions. What do you want to go over, kids? 16. We'll go over, let's see. Yeah, the answers. Now, yeah, 16, I can't tell you really what's going to be on the AP exam. I know but I can tell you for sure there will be an implicit differentiation problem. There will always be one. So this this is nice. So you take the derivative of both sides with respect to x. So you take the derivative of the left side, it's cosine of xy times the derivative of the inside. That's a product. So you had to use product rule for the derivative of the inside. Then the derivative of the other side was just 1. You just didn't distribute. Just one little thing. You want to distribute, and that's only going to happen, the only time you're going to have to distribute with these is if y is inside some other function. Then you will have to distribute. If it's part of a product anyway. If it was just sine of y, that would be okay. Yeah, then we distribute the dy dx terms on the left, the other terms on the right, and then you can divide, you get the answer. Crazy. Good. But then it's just going to be different terms, yeah. Got it down. You're welcome. Yes. And let me see. It should be E, right? Yeah. Well, here's the thing. 14, this is a great question. When they only give you a few points, they gave you the value of the second derivative, and they ask you, which must be true. Understand that when they only give you certain points, that it's going to don't think that it's going to necessarily do what you think it's going to do. See, I look at this and I think, oh, the second derivative goes from 5 down to 0 to -7 and back up. No, you got to imagine the worst case scenario or doing something bizarre. So what if this second derivative at 1.1 didn't go negative? What if it popped back up to a positive? So in other words, the second derivative went from 5 to 0 back up to 4. Right? To be a point of inflection, the second derivative has to change sign. And just because it's 0 doesn't mean it will change sign. It could just go to 0 and then bounce back off. See what I'm saying? So then the second derivative wouldn't change sign. Like if I asked you find the second derivative, you set the second derivative equal to 0 and make a sign chart. You look to see if it changes sign. So in D, it says it's going to have a point of inflection at 1. No, not if it bounces there. So E is the answer because it says the F has a point of inflection. It changes concavity somewhere on the interval from 0 to 2. Well, D could be true, but the reason we can't put that is because it says which must be true. And if you can think of any scenario where it's not, then we can knock that off the list. And you always want to picture that when they give you values, that it does something weird in between. You're welcome. Other questions? Yes, Manny. 28. I don't whine at that one. That was her question. Oh, this is the inverse? Now, when we did this a long time ago, yeah, we did the derivative inverse. Long time ago, we had like a four-step approach. This is the idea behind it. If you have a function, let's say that this is f, and you have its inverse, instead of calling it f to the negative 1, because that gets too crazy, let me call it g. The inverse is what you get when you switch all the x's and y's. And because all you've done is switch the x's and y's to get the inverse, the slopes are just reciprocals, because slope is change of y over change of x's. So if they ask you for the slope on the inverse over here, let's say they ask you for g prime at a, the slope of tangent here, it's going to be the reciprocal of the slope over here on the function. Now, this x-coordinate's different than that x-coordinate. In fact, when x is a on one graph, that's the y-coordinate on the other. So if this is the point AB on the inverse, the point BA is on the function. You've switched them. So one way I think that probably maybe instead of that notation, because that's the formula you will see, if you want the derivative of the inverse g at A, it's 1 over the derivative of the function at B. Now, B, you can write it like that because the reason you can, and I don't want you to get confused by that notation, if f of A, no, if f of B equals A, I'm sorry. If f of B equals A, how would you solve for B? How would you get rid of this function, f? The inverse. So if you took the inverse function of each side, B is simply the inverse of f at A. That's why it's written the way that it is, instead of just saying B. But it just might be easier for you just to remember this formula right here, that g prime of A equals 1 over f of B. So, where this is the point AB and this is the point BA. So now we can put it together. They ask us for the value of g prime of 3. Right. The four steps, because they usually didn't give us point values like this. You put in this value into the y of the function. You solve for x. You take the derivative of the original function and you plug that value in. Yeah. Not negative reciprocal, just reciprocal. So we want to find the derivative of the function at 3. I know it's going to be 1 over the derivative of the original function, not at 3, but at whatever x value gets me 3 on the original. See, normally what we did is we set the whole original function equal to 3. We put in 3 for the y, and we solved for x. They've kind of already done that for us. They told us that it's going to be 6. So it's going to be 1 over, not f prime of 3, but it's 1 over f prime of 6. You plug it into the derivative, and then take the reciprocal. Now, f prime of 6, they gave it to us. Yeah? No? Oh, g prime of A is equal to 1 over f prime of B. Thank you. Good. Yeah, this is the formula that you want. Negative 8. Oh, because when you're looking for the derivative on the inverse at 3, that's when the y coordinate on the function is 3. So you want the x coordinate on the inverse to be 3. So that means the y on the original function is 3. So you got to figure out what's the x. What x makes y 3 on the original function? And you got to look at the points. What x on the original function? They gave you a couple, well, these two choices. No, they're not each other's derivatives, you're saying? No. All right, want me to go through the step way that we used to do it? Okay. So, right. There we go. All right. Now we're in business. Okay. So we want the derivative of the inverse of fg at 3. The first thing that we would normally do is we would put in if we have y equals f of x as the original function, the first thing we would do is we put that value in for y of our original function and solve for x. Because we're trying to find that corresponding point. We can't do it the old-fashioned way for this way. We have to just look at the choices. But one of the things that they tell us is that f of 6 equals 3. So solving for x, we know that x equals 6. So what we do is we find the derivative of the original function at 6 and flip it. So our second step would be to find f prime of x, but again in this case we can't. Our third step would be to plug in that number we got in step 1 into the derivative. So in other words, find f prime of 6. And then we would take the reciprocal. So take the reciprocal, or this would be 1 over f prime of 6. So they told us that f prime of 6 was negative 2. So our last thing we'd have to do is take the reciprocal of that. So wherever they ask you to find the derivative of the inverse, put that number into y of the function, solve for x, plug that value into the derivative, and flip it. Okay, it was just because this way they kind of gave you all the pieces so you couldn't follow the normal steps. Other questions? So it was negative 1/2. Yes. 18. Oh, I'm so glad you asked 18. Okay. They tell you that you have a tangent line to this parabola. They don't give you all the information about the tangent line, but they do say that basically y is equal to some number k minus x. So we know the slope of the tangent line is negative 1. We don't know its y-intercept. And that's what we have to find out. One thing you always want to remember about when you have a curve and a tangent line, at that point of tangency, two things are true. One thing that's true is the y-coordinate on the tangent line and the y-coordinate at this point are equal. The y on the curve and the y on the tangent line are the same here. So the y's are equal. The second thing that you want to remember is that the slopes are equal. The slope of the tangent line is equal to the slope of the curve at that point. All right, so the y coordinates are equal here at the point of tangency, and so are the slopes. Now, because the y's are equal, I could set y on the tangent line, which is k minus x, equal to y on the parabola. But if you look at this, this is an equation with two unknowns. I'm not going to be able to solve for that. That's why you need a second equation. The second equation comes from the fact that when they're at this point of tangency, their slopes are the same. So the slope of the tangent line is -1. The slope of the parabola is the derivative, mean slope, is 2x plus 3. With this second equation, when you set the slopes equal, you can solve for x. And once you solve for x, you can go back to the first equation and solve for k. And in that packet yesterday, I gave you, when you see, then you should know, like little things to know. This is one of them. Anytime you have a tangent line to a curve, at that point of tangency, the y's are equal and the slopes are equal. And that'll get you through those problems. Yeah. Well, the thing is, they didn't tell you anything about it, but you know at this point the y on the tangent equals the y on the curve. So I set this equal to that. No, like you don't know what it is. That's what you want to figure out. Yeah, anywhere. Yep. Well, because I set the y on the tangent line equal to the y on the curve, that didn't help me. But I also know that their slopes are the same. So I set the slope on the tangent line, -1, equal to the slope of the parabola, which is 2x plus 3. That told me where it is. That gave me the x coordinate of the point. Now, if I wanted the y coordinate of the point, I could plug the -2 into either one of these equations and solve for y. But I just didn't need to know that. I just used that to go back to the first equation and get k, which is the y-intercept of the tangent line. Well, when you plug -2 into the first equation, that's going to allow you to solve for k. K is, if this is the equation of the tangent line, that's the y-intercept of your tangent line. Yeah. No, I'm running out of time. 19, real quick. 19, L'Hopital's could have helped you out even though you didn't need it. One thing that you want to know about horizontal asymptotes, they occur, the way you find them is to find the limit as x approaches either -infinity, and you want to find the limit of the function as x approaches +infinity. Now, the only bad thing about this one was it wasn't a rational function. You couldn't just compare the degrees, right? It was a little ugly. So the best way is, if you want to find the limit as x approaches -infinity, all right, see what's going on. Remember when if you have a number like 2 to the -infinity, that's just going to 0. Same thing down here. So you would just get 5. You guys can go. I know you have to go. Plus 0 over 1 minus 0. So that would be 5. So you do have a horizontal asymptote. Y equals 5. To get the other one, infinity over infinity, you don't know what that is. You could use L'Hopital's. You could take, this is not the way you have to. The way they wanted you to do is divide through by 2 to the x and then take the limit. But if you just took the derivative of the numerator and the derivative of the denominator, okay, thank you, then you see that's just -1. And the limit as x approaches anything, including infinity of -1, is -1. So that's how you get the 2. See you later.